Welcome to the Anthropic Claude Certified Architect Foundations CCA-F Question Bank Series. In this video, I've got 10 exam-style practice questions lined up for you, covering the kind of agentic architecture, Claude code, prompt engineering, tool and MCP design, and context management scenarios you'll see on the real CCA-F exam. Each question comes with the correct answer and a full explanation, including why the wrong options are wrong. Here's how to get the most out of this. When a question appears, pause the video, pick your answer, then hit play to check yourself. Ready? Let's dive in. Question 181. An agent retries every tool failure identically. It retries authentication failures pointlessly and gives up too readily on transient timeouts. What should the tool contract provide? The correct answer is C, an error taxonomy distinguishing transient failures that should be retried from permanent ones that should not, so the caller can act appropriately. Retry behavior depends on the nature of the failure, so the tool must communicate which category an error falls into. A permanent failure, like bad credentials, should not be retried, while a timeout usually should. Now, why the other options are wrong. A single retry count in the error message, suggesting how many times to retry, is incorrect. A suggested count without a category still leaves the caller retrying unretriable errors just a specified number of times. Longer timeouts, so transient failures become less common, is incorrect. This reduces one class of failure somewhat, but does nothing to help the caller distinguish categories. A rule that all errors should be retried exactly 3 times is incorrect. A uniform policy is the current problem. 3 attempts at an authentication failure is waste, and 3 may be too few for a recovering dependency. Question 182. A tool that queries a slow reference dataset is called repeatedly with identical arguments. The team wants to cache results, but the dataset does change occasionally. What design is appropriate? The correct answer is D, cache with an explicit freshness policy, a time to live suited to how fast the data actually changes, plus invalidation when the source is known to have updated. Caching is appropriate here, but its correctness depends on a stated freshness policy. A time to live matched to the real change rate combined with invalidation on known updates gives the speed benefit with bounded staleness. Now, why the other options are wrong. Cache results indefinitely, since identical arguments should give identical answers is incorrect. Identical arguments do not imply identical answers over time because the underlying dataset changes. This guarantees eventual stale results. Do not cache, since any staleness is unacceptable in reference data, is incorrect. This forgoes a substantial benefit. Bounded, well-understood staleness is usually acceptable and is a normal engineering trade-off. Cache only within a single conversation and discard afterwards is incorrect. This is safe, but captures only a fraction of the benefit since the repeated identical calls occur across conversations too. Question 183. A tool's backing service can handle 50 requests per second. During peak agent activity, it receives several hundred, and it degrades for all callers, including other applications. What should the tool layer do? The correct answer is A. Apply back pressure. Queue or reject excess calls with a clear retriable error and a suggested wait, so the backing service is never driven past its capacity. Protecting a shared dependency requires limiting what reaches it. Queuing or rejecting excess with a retriable signal keeps the service within capacity and tells the caller how to behave rather than letting overload degrade every consumer. Now, why the other options are wrong? Let all calls through, since the backing service will shed load itself if needed, is incorrect. Relying on the dependency to protect itself is what is currently harming other applications that share it. Retry failed calls more aggressively, so the agent's work still completes, is incorrect. Aggressive retries during saturation add load and deepen the degradation. Increase the tool's timeout so slow responses during peak are not treated as failures is incorrect. This masks the symptom while the backing service remains overloaded and other consumers continue to suffer. Question 184. An internal HTTP API has one endpoint that accepts a filter object able to express almost any query across every table. A team proposes wrapping it directly as a single MCP tool. What should the architect advise? The correct answer is B. Do not wrap it directly. Expose narrow tools for the specific queries the agent legitimately needs, backed by scoped access. Wrapping an arbitrarily expressive endpoint hands the agent effectively unlimited query capability, including over data unrelated to its purpose. Enumerating the real use cases as narrow tools restores a bounded, reviewable surface. Now, why the other options are wrong. Wrap it directly but document in the tool description which filters are appropriate is incorrect. The full capability remains reachable, and a description cannot constrain what the endpoint will accept. Wrap it directly but validate the filter object against a permitted schema in the tool is incorrect. This is closer to correct, but validating an arbitrarily expressive filter language is hard to get right and easy to bypass. Narrow, purpose-built tools are the sounder boundary. Wrap it directly and rely on the API's existing authentication to limit access is incorrect. Authentication establishes who is calling, not what they may query. The endpoint's breadth is the problem. Question 185. An MCP server occasionally returns errors that agents surface as unhelpful failures, and the owning team has no visibility into what is happening. What should they instrument? The correct answer is C. Per tool metrics on call volume, latency, and error rates by error type, plus request correlated logs that can be tied back to the originating agent request. Diagnosing tool failures requires knowing which tool, how often, how slowly, and failing in what way, and being able to correlate a specific failure back to the request that triggered it. Now, why the other options are wrong. A single server-wide uptime check is incorrect. An uptime probe confirms the process is running, while individual tools return errors, which is the actual problem. Verbose logging of every request and response payload, retained indefinitely, is incorrect. Unfiltered payload logging is expensive, hard to search, and likely to capture sensitive data. Structured metrics with correlated logs are more useful and safer. Client-side error counts collected from each agent application is incorrect. Client counts show that failures occur, but give the server team no insight into cause, and they fragment across applications. Question 186. Agents almost always call 3 tools in the same sequence to complete a single business operation, and occasionally get the order wrong. What is a reasonable design response? The correct answer is D. Add a composite tool that performs the whole operation correctly, while keeping the individual tools available for cases that need finer control. When a sequence is invariant and error-prone, encoding it as one tool removes the ordering mistake and makes the business operation a first-class action. Retaining the granular tools preserves flexibility for the exceptional cases. Now, why the other options are wrong. Document the required order in each of the 3 tool descriptions is incorrect. Documentation helps, but still relies on the model composing the sequence correctly every time, which is what is going wrong. Remove the 3 individual tools and expose only the composite is incorrect. This fixes the common path but eliminates the finer-grained control that the unusual cases legitimately need. Add a validation check that rejects calls made in the wrong order is incorrect. Rejecting out-of-order calls turns a silent error into a visible one, which is an improvement, but it still leaves the agent to assemble the sequence. Question 187. Users type terse, keyword-like queries such as refund late. Retrieval quality is poor because these queries carry little context. What technique addresses this? The correct answer is A. Rewrite or expand the query before retrieval, resolving it against the conversation and adding likely terminology. Then retrieve on the improved query. A terse query is a poor retrieval key. Expanding it into a fuller expression of intent using conversational context and domain vocabulary gives the retriever much more signal to match against. Now, why the other options are wrong? Retrieve many more passages to compensate for the weak query is incorrect. A weak query retrieves weakly relevant passages. Asking for more of them adds noise rather than the missing signal. Require users to write queries of at least 15 words is incorrect. Imposing effort on users to suit the retriever is poor design, and users will not comply consistently. Pass the terse query directly to the model without retrieval is incorrect. This removes grounding entirely, which invites an unsupported answer. Question 188. A question requires finding which team owns a service, then finding that team's on-call policy. A single retrieval pass returns documents about one or the other, but never answers the whole question. What architecture is needed? The correct answer is B. An iterative retrieval loop that answers the first hop, uses that result to form the second query, and then composes the final answer. A multi-hop question cannot be satisfied by one query, because the second query depends on the first answer. Retrieval must therefore be iterative, with each hop's result informing the next lookup. Now, why the other options are wrong? A single retrieval with a much higher passage count, so both documents are included, is incorrect. Even if both documents appear, the retriever was never given the second hop's actual query, so the specific policy for the identified team may not be among them. A larger context window, so more of the corpus can be supplied at once, is incorrect. This shifts towards stuffing the corpus and still leaves the model to find a chain that retrieval never targeted. A better embedding model, which would match the compound question more accurately, is incorrect. No single embedding of a compound question retrieves a chain of dependent facts, because the second hop is unknown until the first is resolved. Question 189. A corporate knowledge base contains documents with per-user access restrictions. An assistant must never surface content a given user is not entitled to see. Where must this be enforced? The correct answer is C, as a mandatory filter applied at retrieval time using the requesting user's own permissions, so restricted documents are never retrieved into context. Access control must be applied before content enters the context, using the authenticated user's entitlements. Once a restricted document is in the prompt, it must be considered disclosed, so filtering has to happen at retrieval. Now, why the other options are wrong? In the prompt, by instructing the model not to reveal restricted content is incorrect. By the time the instruction applies, the restricted content is already in context. A prompt instruction is not an access control. After generation, by scanning the answer for restricted content and redacting it is incorrect. The content was retrieved and processed, and detecting paraphrased restricted material in generated prose is unreliable. By indexing only documents that all users may see is incorrect. This enforces the rule by discarding most of the knowledge base, defeating the purpose of the assistant. Question 190. A team supplies the top 3 passages per question. Measurement against a labeled set shows the supporting passage is retrieved for 94% of questions, but for a third of those it ranks 4th to 6th, below the cutoff. What is the appropriate change? The correct answer is D. Raise the number of passages supplied to cover the observed rank range, and add re-ranking so the extra passages do not dilute precision. The measurement shows the retriever is finding the right material, but the cutoff is discarding it, so the cutoff is what must move. Raising it alone would admit more marginal passages, so pairing it with re-ranking keeps the strongest material in the most prominent positions. Now, why the other options are wrong? Replace the retriever, since a third of supporting passages rank outside the top 3 is incorrect. The retriever is surfacing the correct passage in 94% of cases. The defect is where the results are truncated, not in the retrieval itself. Keep the top 3 cutoff and accept the loss, since passages ranked below third are rarely useful is incorrect. The measurement contradicts this. These are known supporting passages that simply fall below an arbitrary cutoff. Re-embed the corpus with a different model so supporting passages rank higher is incorrect. Re-embedding is an expensive speculative change, and the evidence points at the cutoff rather than at the embedding space. Question 191. A corpus mixes prose documentation with pricing tables. Questions about specific prices are answered badly because retrieved table fragments lose their headers and context. What should change? The correct answer is A. Handle tabular content distinctly. Keep each row with its headers and table context when chunking, or query the structured source directly rather than retrieving prose fragments. A table row is meaningless without its headers, so chunking tables like prose destroys the information. Either preserve the header context in each chunk, or query the structured data directly, which is more reliable for precise values. Now, why the other options are wrong? Increase the chunk size so whole tables fit in one chunk is incorrect. This helps small tables, but a large pricing table still exceeds any reasonable chunk, and it bundles unrelated rows together. Convert the tables into prose descriptions before indexing is incorrect. Prose conversion of a large table is lossy and verbose, and precise values become harder to retrieve reliably, not easier. Retrieve more chunks so that the header chunk is likely included alongside the row is incorrect. Hoping the header chunk co-occurs with the right row is unreliable, and the model must then correctly associate them. Question 192. A knowledge base contains an old policy document and its replacement, both indexed. The assistant sometimes cites the superseded version. What is the appropriate fix? The correct answer is B. Mark superseded documents in the index and exclude or deprioritize them at retrieval, so the current version is what reaches the context. The corpus itself contains a contradiction, so the fix belongs in the index. Recording supersession status and filtering on it at retrieval means the obsolete document is not competing with its replacement. Now, why the other options are wrong? Instruct the model to prefer the more recent document when it sees 2 versions is incorrect. This only works when both happen to be retrieved together and the dates are legible, and it leaves an obsolete document occupying a retrieval slot. Retrieve more passages so the current version is also included alongside the old one is incorrect. Including both leaves the model to adjudicate and wastes capacity on a document that should not be in play. Delete the superseded document from the source system is incorrect. Superseded policies usually must be retained for compliance and historical reference, so deletion is often not permitted. Question 193. A long-running assistant conversation also performs retrieval each turn. As history grows, retrieved passages are squeezed out and answer quality falls. What design addresses this? The correct answer is C. Allocate an explicit share of the context budget to history and to retrieval, compacting history as needed so retrieval always retains its allocation. History and retrieval compete for the same finite budget, so the split must be deliberate rather than incidental. Reserving an allocation for retrieval and compacting history to fit keeps grounding available no matter how long the conversation runs. Now, why the other options are wrong. Reduce the number of retrieved passages as the conversation grows is incorrect. This is the failure being described. Progressively removing grounding is what degrades the answers. Truncture the oldest history turns whenever the context is nearly full is incorrect. Truncation without a budget policy still lets history dominate and may discard durable facts established early. Start a fresh conversation whenever the context approaches its limit is incorrect. This resets all conversational state abruptly and forces the user to re-establish context. Question 194. A team retrieves 8 passages and is deciding how to order them within the prompt. What is a sound approach? The correct answer is D. Rank by relevance and place the strongest passages in the most prominent positions, keeping the instruction close to where generation begins. Position within a long prompt affects how strongly material influences the answer, so the highest confidence passages should occupy the most prominent positions, with the instruction near the end where generation starts. Now, why the other options are wrong. Order them randomly to avoid biasing the model toward any particular passage is incorrect. Deliberate ordering is an advantage, not a bias to be avoided. Randomization discards the ranking information the retriever produced. Order them chronologically by document date, regardless of relevance, is incorrect. Date ordering is appropriate only when recency is the question. In general, it buries the most relevant passage. Place the weakest passages first, so the model reads the best material last, is incorrect. Recency of position can help, but this deliberately spends the prominent early positions on the least relevant material and risks the weak passages anchoring the answer. Question 195. A retrieval-based assistant is launching with only a handful of documents indexed. Most questions have no supporting material. How should it behave? The correct answer is A. Detect when retrieval returns nothing sufficiently relevant and say so plainly, rather than answering from general knowledge as though it were grounded. With a sparse corpus, the honest and safe behavior is to recognize when no relevant material was found and say so. Answering ungrounded questions in a system users believe is grounded is the more damaging failure. Now, why the other options are wrong. Fall back to answering from the model's general knowledge without noting the difference is incorrect. Users will reasonably assume the answer is grounded in company documents, which makes an ungrounded answer misleading. Return the closest available documents regardless of how weak the match is incorrect. Weakly related material invites an answer that appears cited but is not actually supported. Delay launch until the corpus is comprehensive is incorrect. This may be prudent but is not always practical, and the system still needs correct behavior for questions outside its coverage. And that's a wrap on this video. Nice work getting through those 10 questions. If this helped, you're going to want the complete set. All 390 exam-style questions, with full explanations across all 5 CCA-F domains, are available in my Udemy course, Anthropic Claude Certified Architect Foundations, CCA-F, 6 full practice exams. The link is in the description below. Make sure you subscribe so you don't miss the next video, where I'll walk you through 10 more questions. See you in the next video.